Welcome to another video series on our proofs. This time we are going to focus on proofs about parallelograms and congruent triangles. Again, these are not required viewings. These are if you wanted to go back and have a second look at what we did in class, or if you were absent during class and wanted to get caught up on what you missed. Alright, so the first theorem we're going to prove in this series is that if a quadrilateral is a parallelogram, then opposite sides are congruent. So we are given parallelogram DQA, and we're asked to prove that DQ is congruent to UA. And yes, there was a typo on your sheet. If you have the original version, there was AU. Now we're switching it to UA just so the parts line up. And then QU is congruent to AD, and that gives us a nice little diagram to refer to. So just like we've done with many of our proofs, our first statement is going to be what we were given. And that's that DQUA is a parallelogram because, of course, the reason we were given it. So what we need to think about is what it means to be a parallelogram. At this point, the only thing that we know about parallelograms is it is a quadrilateral with two pairs of parallel sides. That's what we have right up here at the top. That's the only thing that we know right now that we can use in our proofs when it comes to parallelograms. So since that is the only thing I know, that is actually going to be what I start with. I'm going to start that my opposite sides, and that is going to be DQ and AU, are going to be parallel. So I remember marking these with the little arrow. And then our sides QU and DA are going to be parallel. So that was given to us by the definition of a parallelogram. That's, again, the only thing we know about parallelograms, so it's the only thing that's fair to use in a proof right now. So thinking about what parallel lines do, we have a transversal that's cutting through it here and is forming four angles, angles 1, 2, 3, and 4. Now we know from a previous proof that we have done that alternate interior angles are going to be congruent. That is going to mean that angle 1 and angle 3, since they're alternate interior angles formed by a transversal cutting two parallel lines, are going to be congruent. And that is going to be by the alternate interior angle theorem. Alright, and you can kind of start to see that this is dividing this into two triangles. So we're trying to prove pieces of those triangles are congruent. So what we're working towards in the end is proving these two triangles congruent. So right now we have proved that one angle is congruent. That is one of the things that we have shown. And we're working towards one of those five theorems or postulates that we can use to prove triangles are congruent. So the next thing I'm going to notice is that transversal that I just highlighted is going to be congruent in both of these triangles. So I can say that QA is going to be congruent to QA, and that is by a reflexive property of congruence. So at this point I have an angle and I have a side. I want to work towards having another one of those that is going to match our criteria for proving triangles are congruent. If I go back to my step where I had angle 1 congruent to angle 3, because of alternate interior angles, I could have also marked that angle 2 and 4 were congruent. Now, this is another place where proofs can be a little bit different from person to person. These two technically could have been combined into the same step because they had the same justification. The reason I didn't was just to give us a clear illustration that this gives us another congruent angle. So we're looking at angle, side, angle. And so by putting those together, if I look back at my diagram, I have a side that's included between two angles. So we can use the angle, side, angle to say that DAQ is congruent to UQA. And that's by the angle, side, angle postulate. And then my final statement is I'm looking at these little pieces. Since I know that these two triangles are congruent, that means these are going to be congruent and these are going to be congruent, which is my proof statement right here. Alright, so that's our final step. We're going to show that those are congruent, and that is, of course, by CP/CTC. Congruent parts of congruent triangles are congruent. So we have now proved that if a quadrilateral is a parallelogram, then opposite sides are congruent. This is now fair game to use in any future proofs. Alright, stay tuned. Ms. Blaylock will be here with another video next.